Welcome to Sidschemistry and welcome to the show Crack the 7. In the show today we are going to discuss various questions and answers based on the concentration units of the solutions, that is homogeneous mixtures. Here I am rolling up various concentration unit formulas. You can take a note on them. So enjoy the show and crack the 7. Now presenting very first question of the show, and the question is, what is the relationship between normality and molarity? Options are: option A, normality is equal to n factor into molarity. Option B, molarity is equal to n factor into normality. Option C, n factor is equal to normality into molarity. And option D, n factor. Dear friends, when we compare the formulas of the normality and molarity, the formula of normality is equivalence of solute per liter of solution, and formula of molarity is moles of solute divided by liter of the solution. These two formulas are compared, and when they are compared, two comparison factors came. The one is that equivalence and the other is mole. Equivalence is weight upon equivalent mass of the solute, while mole is the weight and molecular mass, weight upon molecular mass of the solute. So when we compare these two, again the one more factor comes into the comparison, that is equivalent mass and the molecular mass. Equivalent mass is the molecular mass upon n factor, and molecular mass itself is calculated by the addition of the atomic masses. So finally when we compare, n factors comes into the picture. So the final answer of this solution will be normality is equal to n factor into the molarity. And when you do calculation, when you do comparison, this formula will be derived. So this formula is very important, and correct answer of this solution is normality is equal to n factor into the molarity. Now presenting second question, level 2, and the question is, the concentration formula which is affected by deviation in temperature. Options are: option A, mass percentage; B, volume percentage; C, molality; and D, mole fraction. Dear friends, first of all we need to understand how temperature can affect the formula or the concentration unit. Temperature can affect the concentration unit if the volume is present anywhere in the formula. So we have all the options, that is mass percentage. In mass percentage formula, no volume is used. Volume percentage, definitely volume percentage has volume, both solute and solution. Molality, no volume is utilized. And mole fraction, again no volume is utilized in this formula. So the only one unit which is affected by the temperature change is the volume percentage. So correct answer for this question is option B, volume percentage. Now presenting third question of the show, question 3, level 1, and the question is, this concentration formula is associated with Raoult's law statement and it is unitless. Options are: option A, mole fraction; option B, molality; option C, molarity; and option D, mass percentage. Dear friends, there are two hints are given in this question. The one is that Raoult's law, and the other is that the concentration formula is unitless. So first of all, Raoult's law. Raoult's law states that the vapor pressure of the solution depends on the mole fraction of the solute in solvent present in the solution. So the correct answer is mole fraction for this question. However, if we don't know the statement, we know the second hint is that concentration formula is unitless. So out of the given formulas, only one formula, that is mole fraction, is the unitless. So correct answer for this question is the mole fraction, that is option A. Now presenting fourth question, level 1, and the question is: empirical formula mass of a compound is used to calculate which concentration unit? What is the effect of temperature on it? Options are: option A, normality, no effect of temperature; normality, changes with the temperature; option C, formality, no effect of temperature; and option D, formality, changes with the temperature. Dear friends, first of all we need to understand both the units, that is normality and formality, because all the options are divided in two categories, that is normality and formality. Dear friends, normality utilizes equivalent mass of the solute, while formality utilizes the formula mass of the solute. So we have correct answer with the formality. Now second is that is changes with the temperature or not. Definitely formality uses the volume of the solution and it changes with the temperature. So correct answer for this question is formality and changes with the temperature, and therefore the correct answer for this question is option D, formality, changes with the temperature. Now presenting question 5, level 2, and the question is: what is the relation between mass percentage of solute and molarity? Options are: A, molarity is equal to mass percentage into density into 10 and the whole divided by molar mass of solute. Option B, molarity is equal to mass percentage into density into 10 and the whole is divided by molar mass of solution. Option B, molarity is equal to mass percentage into density into 100 divided by molar mass of solute. And option D, molarity is equal to volume percentage into density into 10 divided by molar mass of the solute. Dear friends, molarity utilizes the mole per liter formula, while the mass percentage is the mass of the solute upon mass of the solution multiplied by 100. So when we want to convert this formula into the molarity formula, we have to use density. Now when we compare and when we derive the formula, the correct answer for this question is option A. So molarity is equal to mass percentage into density into 10 and the whole is divided by molar mass of the solute, and the correct answer for this question is option A. Now presenting 6th question, level 2, and the question is: homogeneous mixture is also called as dash. The different concentration units are used to describe the quantity of solute to achieve dash. Dear friends, there are two questions in one question. First is that what is homogeneous mixture, and second is that why different concentration units are utilized to describe the quantity of solute in different ways. So let us see the options. Option A, colloids sustainability. Option B, solution sustainability. Option C, colloids precision and suitability, and option D, solution precision and suitability. Let us understand the colloids and solution words. Colloid is a heterogeneous mixture, it is not homogeneous mixture, while solution is a homogeneous mixture where the physical boundaries of solute and solvent are now not visible. So homogeneous mixture is a solution. Now sustainability means different concentration units are keeping the concentration for a long time intact, that is called as sustainability. But sustainability is really not an issue for any of the concentration units. So therefore sustainability is not a typical character we have to put here. However, precision and accuracy are important characters when we are preparing solution. Precision is that when you are preparing again and again the same concentration unit or same concentration solution, we have to come to close to the previous one. And suitability is what? Suitability means user friendliness. To prepare the particular concentration unit, it should be user friendliness. So it should be easily prepared. So correct answer for this question lies with the solution, then precision and suitability. And the correct answer for this question is option D, that is solution, precision and suitability. Now presenting 7th question, level 3, and the question is: remark on given statements. 1. Effect of temperature can be seen in volume-based units only. 2. Molality is better unit than molarity. 3. Parts per million is used when solute is present in very high quantity. And options are true, false, false. B. True, true, false. C. False, false, false. And D. True, true, true. Dear friends, let us understand all the 3 statements. Number 1. Effect of temperature can be seen in volume-based units only. Definitely, effect of temperature can be seen in volume-based unit only because when temperature raises, the volume of any of the state of matter will be raised, and therefore, whenever it is applied, the concentration formula will be changed. So the first statement is a true statement. Now second statement is molality is a better unit than molarity. Molality is a weight-based unit where we don't use volume, and molarity is a volume-based unit where we use volume. So definitely the unit which gives more precision is molality, and we can write that molality is a better unit than molarity. So second statement is also true. Third statement, parts per million is used when solute is present in very high quantity. No. Parts per million is a kind of unit which is used to determine when solute is present in very small quantity, which is not easily measurable. So it is applied in RO water solute determination, that is called as TDS, total dissolved solute. And then it can be used to calculate the particles present in the air. So ppm is used when the solute is present in very small quantity but not very high quantity. And the third statement is false. So correct answer for this statement are option B, that is true, true and false. So option B is the correct answer. Now it's a turn to get add 2 brain points. Number 1, remember all these concentration unit formulas. Number 2, understand the application of each of them. And number 3, write once a week these formulas to get it absorbed on you. So this is all about add 2 brain points and today's show Crack the 7. I hope you enjoy. Namaste.